Hey guys, welcome back. I'm feeling a lot better today. I had a bit of blues yesterday. Talked to my uncle, and he's running a marathon. He's actually run the Memorial Marathon, every single Memorial Marathon. I think there's less than 20 people who've done that and have kept that up. And anyway, so he's planning on running the Memorial Marathon this weekend, but because of COVID, he has to do it virtually. So he's running in a park in South Oklahoma City this weekend, in a loop that's a mile and a half. So he'll run it 12, 13 times, however, just the same loop over and over and over again to get in his mile, or to get in his marathon. So anyway, I feel in a lot of ways what I'm doing is very similar to what he's doing, in the fact that I'm doing all the work. I'm training for the marathon, but there's no enjoyment, or very little enjoyment. There's no woohoo, congratulations, you did it. There's no cheering, there's no crowds, there's no all the fun part of the feeling of accomplishment and everything of running a marathon. I feel like it's kind of stripped away. So it's just it's not that much fun. So we're doing all the math. You guys are learning. When I see your test scores, I see, and I look at your test. I see your work. I know you guys are learning. So I know that's good. I see evidence of it. But it's so much more enjoyable to do my job in person with you guys there, to be able to see you have those light bulb moments, to go through not knowing how to do something and then now knowing how to do it. And that's my job. That's what I love doing. And if you take out the interpersonal aspect to it, the whole relational aspect to it, it makes my job not really worth doing. I mean, I really kind of don't want to do it. So anyway, it's going to be better, and I'm going to keep trying to motivate myself to do my best to work hard for you guys, because I know you are there. I know I'm not just sitting in my room talking to myself, even though I am. And I'll try to stay lighthearted, but it's just, we're all going through a lot right now. And so I feel you in that too. So I hope your situation at home is going well. I hope you guys are doing well. And I think I'm going to put a survey out just to see how things are going in general, and to see if there's anything I can do to make it better for you guys again. So probably put that survey out on Friday. Anyway, today we're going to just do what we did yesterday, kind of more of the same things. And so just, if you breeze through yesterday's, we'll breeze through it today again. And if you struggled yesterday, hopefully I can show you some different ways to approach it so that maybe it'll click this time. But a lot of this is just review from what we did back in middle school. So we want to find the slope between 2 points. Our slope formula is y2 minus y1 over x2 minus x1. This is the delta y, which is the change in the y over the change in the x. If we look at those points, the change in the y is going to be this blue right here, the rise, and the run is going to be the change in the x, which is the green right here. I forgot to color code those, but it looks a lot better now. Saving. Anyway, so delta y over delta x, it's a rise and a run, the same thing we did with the Pythagorean theorem, and the same thing, the difference between these two, that we did with the distance formula as well. It's just now we're applying it to the slope formula, which if I only taught the formula and I didn't actually visually get to see what was going on, I would be so bored teaching algebra. It's just, oh man, I can't do it. I really can't. And maybe that was part of my problem yesterday, but that's okay. Today's a better day. So what we want to do is find the change in the y and the change in the x. Well, if we look at the change in the y, we're going down 4, so you can just count 1, 2, 3, 4, so minus 4, okay? And our change in our x, our rise and our run, so our rise is going down 4, our run is going over to the right 3, so our slope would be negative 4 over 3. Now, how could we find that using the formula? So if we didn't graph it out and look at the components, the delta x and the delta y, instead we could use a formula. So we're going to label our ordered pairs, the first one and the second one. So this is x sub 1 and y sub 2. It's our x term from our first ordered pair and our y term from our first ordered pair, and then x2, y2. So we're going to do y2 minus y1, so 1 minus 5, okay, and then 5 minus 2. And 1 minus 5 is negative 4, 5 minus 2 is 3, so the change is going down 4 and to the right 3, so rise negative 4 and run 3. You can do the same thing going left and up. You get the exact same answer. They would just both be negative, and put the negative on the bottom, so it's fine. Yeah, so that's how we find the slope. What does it mean for lines to be parallel? So parallel lines are coplanar and they never intersect. And we can tell here that they're on the same Cartesian plane, right? Rene Descartes' plane he's got going here. Which one of these are parallel? Well, we can tell by their slope. So if we look from E to F, it's rising 0, running 4 or whatever. So that's a slope of 0. CD is going up 1 and over 4, and AB is also going up 1 and over 4. So they're both a slope of 1/4. And if we notice, if I drew the components here, up 1 over 4, it's the same components we have on this one, right? And if I extended that line forever, they're going to rise and run at the same rate. They're still going to go up 1 over 4, up 1 over 4, up 1 over 4. And so they're never going to intersect because they're going to keep going at the exact same rate, which means that if they haven't intersected now, they're never going to intersect, and that's because they're two unique lines. So we know these two have to be parallel, and the reason they're parallel is because they have the same slope. So parallel lines have the same slope. We need to remember that, okay? So are these two lines parallel? So this is similar to what we saw yesterday. So what we want to do is we want to write the equation, and when we write the equation, we're going to be using slope-intercept form. So in the slope-intercept form, the m stands for the slope, and the b is the intercept, the y-intercept, which is where it intercepts the y-axis. So if we look over here for y1, that's our line 1. We want to find, okay, our y-intercept is 4, but what's our slope? So it looks like we're going down 2 and over 3. So it's going to be negative 2/3 x, that's our slope. The blue part's our slope, negative 2/3, because we're going down 2 over 3. So rise negative 2 and run 3. And then we're going to add our y-intercept to it, our plus b, which in this case we said the y-intercept where it crosses the x-axis, the y-axis is going to be 4, so plus 4. Now what about our y sub 2, which is our second line? So now it's going to have a y-intercept of 2, and our slope is still down 2 over 3. So negative 2/3 x plus 2. What do you notice about these two lines? Well, they both have the same slope, right? Right here we have this negative 2/3. Over here we also have the negative 2/3. So if they have the same slope, then that means that they have to be parallel, because parallel lines have the same slope. I'm going to repeat that over and over again because you guys need the repetition. So that means that they're going to keep going at the exact same rate. Down 2 over 3, down 2 over 3, right? Down 2 over 3, down 2 over 3, over and over and over again. So they're never going to intersect. Now another thing we can do is if we want to write an equation of another line that is parallel to line 1, it doesn't matter. I did it to the other one. It doesn't matter what our y-intercept is as long as it has the same slope. So if I wanted to raise this whole line up here and instead do plus 3, that would be totally fine. See, they're still going to be parallel because they still have the same slope. So the y-intercept doesn't matter as long as it's not exactly the same. Because if this was 4, then they would be the exact same line, right? And then they're going to intersect because they intersect at every single point because they're collinear, right? Because they're the same line. So you could put it up at 5, you could do 4.5, you could put it down at 1. It does not matter what this is. So you could write a general form of the equation. It would be negative 2/3 x plus b, where b is just some y-intercept. I guess I should probably move that up for any value. So it really doesn't matter what you set the value of b to be. It'll be parallel because the most important thing is they have the same slope. All right, so are these two perpendicular? Do they look like they're perpendicular? Yeah, they look perpendicular to me, maybe to the untrained eye, but how can we prove that they're perpendicular? They do intersect, so they're not parallel, but they need to intersect at a right angle. Well, I can't measure an angle. Well, technically I could if I really wanted to. I could measure an angle. Oh, this is exciting. I didn't plan on doing this, but I can. Oh, so it's not exactly 90 degrees. Instead, it's actually about, I don't know, 98 degrees? Huh. So, well, there you go. Are they perpendicular? No, but we don't want to do that. That's kind of cheating. We want to do this with a Cartesian plane. So what do we know about slopes of perpendicular lines? So they are the opposite reciprocal. So the opposite means it has the opposite sign, so like plus or minus. So, and the reciprocal means we switch the order of the top and the bottom. Okay, so we want to do the opposite reciprocal. So let's find the equations of the lines. So this one has a y-intercept of 5, and the slope is going down 1 over 1, down 1 over 1, down 1 over 1. So it's going to be negative 1, so negative 1x plus 5. This one here has a y-intercept of 0, and it's going up 1, 2, 3 over 2. So that's going to be 3/2 x plus 0. And I'm going to put the 0 there, and technically like the 1 there would be rewritten. This would be y is equal to negative x plus 5. And down here we'd probably write this as y is equal to 3/2 x, and then just leave it off because the additive identity and the multiplicative identity, right? We already know that stuff. Okay, so I'm going to go ahead and get rid of that, but technically that's how you'd write it. Simplified, I'm just writing it here so you can see what's going on. So look at their slopes. Are they opposite reciprocals? No. What is the opposite reciprocal of -1? So if we go from -1, then we want to switch it from negative to positive, and then do the reciprocal. Well, this is technically 1/1. When I do the reciprocal, it's still 1. So the opposite reciprocal of -1 would be +1. So how could I fix this? So instead, starting here, I want to go a slope of 1, so I have to go a little bit down. There we go. Now they would be perpendicular because this one has a slope of +1, this one has a slope of -1. You know what? It looks like my x and my y scale are not the same. Like the thing is a rectangle, it's stretched out. Anyway, if it was right, then that would actually be a right angle. The other thing we could do is a slope of the opposite reciprocal of this one. So I'm going to go back to where it was. And then how could I change this one? Well, what's the opposite reciprocal of 3/2? So here I have 3/2. Opposite reciprocal, I'm going from positive. Now I'm going to do negative. And then reciprocal, I'm going to switch the order. So it's going to be 2/3. So instead of going up 3 and over 2, I need to go down 2 and over 3. So that would need to go through this point right here. So they would need to intersect right here. And I'm going to see if I can do this. In fact, it would be easier if I just draw another line. Yeah, so give me just a second. So I'm going to go through this point here, through that point right there, and that would be it. So down 2 over 3, down 2 over 3. Yep, that's it. And those two technically should be perpendicular now, if the x and y scale were preserved. And they're not, because my bad. But anyway, technically that's how that works. So are they perpendicular? We need to have opposite reciprocal slopes. All right, slope-intercept form, y is equal to mx plus b, where m is the slope, right? The b is the y-intercept, which is where it intersects the y-axis. On this one, because it's in y by itself, right? So it's in the y is equal to slope-intercept form. Whatever's in front of the x has to be the slope. And then whatever's after the x term has to be the y-intercept. So we have a slope of 7/5, rise 7, run 5, and a y-intercept of -4. Whoa. Okay, so that's it. That was short, nice, and sweet because we did pretty much the same thing we did yesterday. Hopefully that was a better explanation. If you still are struggling with any of this stuff, please join me at 11 for our Google Meet so I can answer your questions. All right, find the slope of the line through each pair of points. So on this one here, just want to do the slope formula. It's boring because we're not graphing out, but that's okay. So y2 minus y1, x2 minus x1. You'll have the formula on the test, by the way, and the practice test. So we're going to do -4 minus 6. So -4 minus a -6. So be careful because when we do minus and negative, it becomes plus a positive. That's a very common mistake. So -4 plus 6 is going to be +2. And then 19 minus 3, which is 16. We can reduce that fraction, and we should, which would be 1/8. So we're rising 1 and running 8. So it's a very shallow slope, but it works. Find the slope of each line. So this is not in slope-intercept form. So we can't just take this -7 and say that's our slope. That's wrong. So what we need to do is get the y all by itself. So what I'm going to do first is I'm going to move the 7 to the other side by the 7x. So add 7x to both sides because we're going from subtracting. If we add 7x, it'll go back to 0, right? So add it to both sides. These are not like terms. This is not 15x. It's not just 15, or this is negative. So it's not just 1 or 1x or anything. We have to put it to the side. So when we do that, we're going to have 7x minus 8. Just put them next to each other, right? Because they're not like terms. We can't add them together. That goes to 0, so we have -2y on this side. Now, I don't want -2y. I want just the y, so I need to divide both sides by -2 and divide all the terms by -2. So we're distributing a division of -2, essentially is what we're doing, or -1/2. Through that. So not that big of a deal. I guess I could show that. So what we're really doing is we're multiplying both sides by negative, so times -1/2. And over here I'm doing times -1/2, and I'm distributing that through to both terms. And that's why you see the division -1/2. So anyway, technically that's what we're doing, but it works this way just fine. So -7/2 x, and then -8 divided by -2 is going to become +4. I do need to fix that because that is wrong. That should be +4, and you guys will correct me if I don't, so I will. I'm with it today. Like you can tell, I took a 2-hour nap. All right, so -7x, -7/2 x plus 4 is equal to y, but we want to rearrange it so we can do the symmetric property of addition, of equal. Yeah. Sorry, the symmetric property of equality. SYM prop of equality. Yeah, so we can switch the order about the equal signs. So that's going to leave us with y is equal to -7/2 x minus 4. So now that it's in slope-intercept form, the y is by itself. Whatever is in front of the x, like the -7/2, that has to be our slope. Ta-da, done. You are going to have, I think, 1 or 2 problems on the test where you have to go from, well, something similar to standard form, kind of like what we have here, to y-intercept form. So make sure you know how to do it. Show your steps. Don't just write down the answer, and we'll be good. Write an equation of a line parallel to the given line. Oh, these are so easy. So this is already in slope-intercept form. The slope has to be 7/5, right? So our slope is 7/5. The y-intercept is -4. We don't really care about that. We want to write one that's parallel. So parallel lines have the same slope. So I want to write an equation that has the exact same slope as this one. So I'm going to do 7/5 x, and then just give it a different y-intercept. So don't do -4. You can do +4. Or anything else as long as it's not the same line. All right, write an equation of a line perpendicular. So perpendicular lines have opposite reciprocal slopes. Okay, so if this one has a -1/2, now it's going to be positive, and the reciprocal of 1/2 is going to be 2, so positive 2x, and then we'll do -4. Again, you could do anything. You could just do +0 if you wanted to. Just make sure it's different. Oh, actually, you could do +4. You can make it where they intersect on the y-axis if you want. That would actually work just fine as well because they're not the same line because they have different slopes. So, no big deal. Determine if the lines are parallel, perpendicular, or neither. So to do that, we have to first get this in slope-intercept form, and it already is because we have the y's by itself on one side of the equal sign with no coefficient. So one of them has a slope of 1/2. Okay, the other one has a slope of -2. Are those opposite reciprocals? So if I take 1/2 and I make the going from positive to negative, and then I flip the order, that's going to be -2/1, which is -2. So they do have opposite reciprocals, so they are going to be perpendicular. You don't have to write the full word perpendicular. You can just draw the symbol if you want. Ta-da, upside down T. And the symbol, by the way, for parallel is just 2 oversized lines. Perpendicular is going to be there, and then neither is just neither. All right, 23. We want to draw a line that is, so write the equation of a line and then give it an equation of a line that's parallel to it. So it looks like we're going y-intercept of 0 and we're rising 2, running 3. So that's going to be 2/3 x plus 0. Now if we're doing plus 0, technically we can just leave that off, because when we add 0, that same thing is just not doing anything. So you just do 2/3 x. So if I want to write an equation of a line that's parallel to it, it means it's going to have the same slope. So I'm going to do 2/3 x, and then I'm going to do plus 3. So I'm going to take this line, and I'm now going to start at plus 3, which is right up here. And then I'm going to rise 2, run 3, down 2, left 3, and you can draw a straight line between those. But because I have the magic of editing, was there the whole time. So cool. All right, same thing now on 27. I think, let me pull up the assignment real quick. Now we're doing one perpendicular to it, so no longer parallel. So if it's perpendicular, we have to do opposite reciprocals. So perpendicular lines have opposite reciprocals. Slopes. Okay, so find the equation of the line. We got a y-intercept of 3. Our slope is down 3/1, so that's a -3. So -3/1 x, and then plus 3 for our y-intercept. Okay, so I'm going to do another line, and now I want to do the opposite reciprocal of -3/1. So the opposite reciprocal of that is going to be from negative to positive, and then flip the numerator and denominator, so it's going to be positive 1/3. So we have 1/3 x, and then I can make it go wherever I want. And I'm going to start it out at, we'll just do plus, no, I'm going to do minus. Yeah, that's funny. So we'll put it at -3. So I'm going to start at -3. Then I'm going to do a slope of 1/3. So I go up 1 and over 3, down 1, left 3. And then I can draw a line. And I will have to cheat and use my little tool And there's my line. Of course, you'd want to draw arrows on it so it's not a segment. And that's it. These two should be perpendicular. And because as you can see, this one's actually a square, so a rectangle, it looks like it's perpendicular. I really need to fix that problem, don't I? Hey, that's it. We came in under 20 minutes. See you. Bye.